Okay, this is the Geometry Unit 4 Lesson 1 video. A lot of vocabulary in this first lesson. It's introducing us to the concept of polygons. So I'm going to start by just going over some of the terminology that you need to know about polygons and what they are. So a polygon literally means many sides. So what it refers to any shape made up of straight line segments. So some key concepts there. So it's any shape made up of straight line segments. That would be a polygon. This would be a polygon. These are all polygons. Rectangles are polygon. Triangles are polygons. You get the idea. So polygons are made up of straight line segments that are connected and enclose a single space. So what is not a polygon? What is not a polygon? Well, three things. You can have no gaps, meaning that's not a polygon. You can have no curves, which means this is not a polygon. And they can have only one space, meaning this is not its own polygon. It is two separate polygons that happen to be connected, but it is not a polygon in and of itself. So let me fix that letter there. So that's one major concept you need to know. So a polygon is made up of many sides, or it means many sides. It's all made of straight line segments, no gaps, no curves, and encloses only one space. When we look at a polygon, we have two main things that we're looking at. We have the sides of the polygon, which would be like this. This is the side, a side. And then we have these items here, the corners, which are each called a vertex. So those are the main parts of a polygon. Also, within a polygon, we have lines that connect two vertices, and that is called a diagonal. And then one other thing that we have here that we want to talk about is each of these is what we call an interior angle. So those are kind of the main components or main parts of a polygon. I'm going to write that as the header here, parts, polygons. So those are your parts of your polygons right there. All right, so let's look at some categories that we can put polygons in. So let me kind of just draw a line here. So polygons can be either, sorry about this, concave or convex. Concave versus convex. So convex polygons have all sides, all the vertices or the vertex. Each vertex points outward from the center. Okay, there is no kind of part where it's going inward. Whereas concave polygons have, in a sense, a cave, a place where they've caved in, and so concave means it points inward at some point. So that's one major that's one set of categories you need to be aware of: concave versus convex. We also can talk about their sides and angles. So some polygons will just have sides that are a variety of different lengths, whether they're concave or convex. But when we talk about ones where they do have the same side lengths, let me try to draw one here. Pretty good. This would be what we call an equilateral, which means that they have equal sides, which means that all these sides are the same. Whereas on the other hand, if we have some where all of the angles are the same, we call that equiangular. Same angles. So maybe say equal angles. So those are not necessarily always together. You can have a polygon that's equilateral or equiangular, but when you do put them together, okay, so when you combine the two, you get a regular polygon. So a regular polygon is going to be one where you have all sides and all angles are the same. Sides are all the same. Angles are all the same. So that's what we have when we say that you have a regular polygon. It's basically both of these together. All right, so that's a lot of the vocab that you're going to be responsible for. So if you go down here, this is going to be where you're going to be saying a number 1 through quite a ways down, through at least number 11, it looks like. And then the next little part is going to be talking about the different angles. One thing before we get there, I'll put this in the notes, but you need to be familiar with the names of polygons up to 10 sides. They're listed in this table 1.1. I'll add it to the notes. I'm not going to go over that. A lot of that you're going to be familiar with, but if it has 4 sides, it's a quadrilateral. If it has 8 sides, it's an octagon. So you need to know those names you see on that table right there, but I will not go into detail on that during this lecture. So the next big section is about the angles. So when we talk about that, we are going to look at 3 main things, and then we'll also talk about diagonals as well. So when we look at a polygon, a regular polygon, let's go ahead and do octagon, if I can get one drawn up there. So let's say this is a regular octagon. I know it's not exact, but bear with me. So this is going to be a regular octagon, which means that it has 8 sides. And that value we call n. N is the number of sides. So this n is going to be 8. Fix that. Sorry about that. Made a little mistake there. That n value is going to be what we use to calculate the different measures of the angles. So let's say I want to know what is the sum of all of these 8 angles. If I add them all up, and what's cool is we actually have a way of doing that. Let me draw another regular octagon. I'll kind of show you how this comes to be. So let's say I have this regular octagon. If I go through this and I draw lines for all the diagonals from one point, I end up with 1, 2, 3, 4, 5, 6 triangles. And if you'll notice, those 6 triangles added up are all the angles of that. And so from this idea, we get a formula for what we call the polygon angle sum. So I'm going to scroll up here so we can see. Right here, polygon interior angle sum. So I'm going to write that down, polygon interior angle sum. And the formula we get is n minus 2 times 180 degrees. So what you're going to do is we're going to take the n value, which we found was 8 because it's an octagon, and we're going to do 8 minus 2 times 180. So jump over to my calculator, and we're going to do 8 minus 2, and then we're going to do that number, which is 6, and we're going to multiply it times 180, and we get 1080. And so that means that for an octagon, it has a total angle measure of 180 degrees. That means all those green angles that I marked have a total measure of 180 degrees. So that's the formula for polygon interior angle sum. Now, what about each individual? This is going to be the formula for polygon interior angle, not the sum. To do that, it's the same formula as the previous problem, but divided by n. So basically, we're going to take the total from our first part, and we're going to divide it by n. So we already know that the answer was 1,080, and we're going to divide that answer by 8. And so we're taking the total, and we're dividing it by 8 to find out how much each one of these angles has to equal. So we're going to hop over here and do 1,080 divided by 8, and we get 135. And that is the measure of each angle of an octagon. So far, we've gotten the total sum of the angles. We've gotten the measure of just one of those angles by dividing that answer by n. And now we're going to find the measure of the exterior angle. So the exterior angle of a polygon is the following angle. So again, we have our octagon here. The exterior angle is referring to this angle. If I extend this out, it's talking about this angle right here. So we already found that this angle was equal to 135 degrees. So what we find is that if I were to kind of take this little section right here and look at this up close, I'll see the following. I have a line, I have a 135 degree angle here, and I'm looking for this angle right there. And since these are a linear pair, we know that 180 minus the interior angle will give us the exterior angle. So in our case, we're going to have 180 minus 135, and it gives us 45 degrees. And that's the measure of the exterior angle of that polygon. All right, I'm going to draw another octagon here. Whoa, let's try again. All right, so the last thing we're going to learn to calculate is to calculate the diagonals. Now the diagonals would be as if I were to draw a diagonal from every single corner to every other corner in this figure, and you can see it gets to be a lot quick. So I don't want to have to draw every single one of those and count them. But the formula for finding the diagonals is the following: n squared minus 3n divided by 2. That gives me the diagonals. So we know what our n is. Our n is 8. And so if I want to know the number of diagonals in a polygon like you see here, I'm going to do, again, n squared minus 3n divided by 2. n is 8, so I'm going to do 8 squared minus 3 times 8. All I'm doing here is just plugging in those numbers into the place where they belong in the formula. 8 times 8 is 64. 3 times 8 is 24 divided by 2. 64 minus 24, 40 divided by 2 is 20. So there are 20 diagonals, and you could confirm that by going and counting all of these, but that is going to be the number of diagonals. So those are the formulas that they introduce here, and you don't have to do much with them, to be completely honest. So I'm just going to talk you through. So we've already talked through numbers 1 through 11. Starting in number 12, 1 through 12. Starting in number 13, you need to identify the correct formula. 13, 14, 15, and identify the correct formula. We already talked about how you name polygons. It's number 16. We have more vocabulary in number 17 and 18, so a lot of vocab. And then starting here, we have how many diagonals does a triangle have? That means you have an n value of 3. How many diagonals does a hexagon have? That's an n value of 6. What about a nonagon? That's an n value of 9. Heptagon, that's an n value of 7. So in all of those, you're finding the diagonals. So you're going to use this formula that I just showed you right here. And we're going to, sorry about that. You're going to use this diagonal formula to find the diagonals of those different shapes. And then starting in number 23, you're going to not complete 23 through 28. So what I'm telling you is to go ahead and answer 23 through 28, and I will fix your score. You're not responsible for 23 through 28. I want you to focus on the vocabulary. So I'll put a note about that on the classroom page for this so that you know not to worry about 23 to 28. And once you've answered the questions in this lesson, I will go back and fix your score to not include those numbers. All right. That's it for lesson 1.